Hey guys, welcome to eMaths. Let's do some maths for fun. Today, we will be starting a new series on quadratic equation. Quadratic equation is one of the very basic topics in algebra. My question is,
二次方程式の解の公式を答えなさい。
x イコール 2a 分のマイナス b プラスマイナスルート b 事乗マイナス 4ac。
こりゃ驚いたな。
I mean, have you ever wondered, where did we get the quadratic formula? What is the discriminant in the formula? Sum of roots and product of roots, how do they work? And finally, is there any other method to solve quadratic equation other than factorize, completing the square, graphical method, or using formula? And this is the very reason I started this series, because the new method was just proposed in December 2019. I really wish that I learned this in high school. Anyway, are you ready? Start off! This is how we define a quadratic equation. An equation of second degree, meaning it contains at least one term that is squared. It can be written in the standard form ax squared plus bx plus c with three conditions. A, b, and c are real number constant or numerical coefficient. A cannot equal to 0 because we need at least one term that is squared. And x is an unknown variable. Now you may ask, why do we need to write the equation in so-called standard form before we solve the equation? Well, it's actually because the zeros of quadratic function fx equal to ax squared plus bx plus c are solutions of associated quadratic equation ax squared plus bx plus c. Hey wait, what is zero of the function then? It's defined as any replacement for the variable that will produce an answer of 0. For example, let's say we have a function of fx equal to 2x minus 4, where x is the variable. In order to get an answer of 0, we need to replace x with 2, right? So that we have 4 minus 4, which is 0. Now we can say that 2 is the zeros of function fx equal to 2x minus 4. Graphically, it is where the graph of function cuts x-axis, and at that point fx equal to 0. However, this is only for linear functions. For quadratic function, we can have real number zeros or imaginary number zeros. If quadratic function ax squared plus bx plus c have real number zeros, then the quadratic equation will have real number solutions. Same thing for imaginary number solutions. Typically, if the zeros or solutions are real number, they are also the first coordinate of x-intercept of the graph of quadratic function. For the imaginary zeros of function, I will explain together with the discriminant in the later part of the video. Moving on. To solve an equation, we need two more friends, which are the equation solving principles, namely the principle of zero products and the principle of square roots. Principle of zero products states that if a times b is 0, then either one of them or both of them equals to 0. While principle of square root states that if x squared equal to k, then x equal to positive square root k or negative square root k. In other words, if you solve x squared equals to 4 like this, negative 2 is going to cry, I tell you. Great, I thought it's enough nonsense in this video. We'll quickly solve some quadratic equation using the principle just now. For question A, we subtract 3 from both sides. Factor out using the reverse point method. 2x squared is x times 2x, while negative 3 is 1 times negative 3. So that when we cross multiply, the sum of products will be equals to negative x. Now the product of these two brackets equals to 0, which means either one of them or both of them equals to 0. By principle of zero products, x plus 1 equals to 0 or 2x minus 3 equals to 0. Solve them one by one, we will get x equals to negative 1 or x equal to 3 over 2. Graphically, this is a graph of function fx equal to 2x squared minus x minus 3, which is exactly the same as standard form of the equation, right? We can see the graph cuts x-axis at negative 1, 0 and 1.5 zeros. Look at the first coordinate of this x-intercept. They're the same as a solution, isn't it? which means our definition from earlier holds true. Don't forget question B. We add 10 to both sides. Whole equation divided by 2 by principle of square roots, x equal to positive square root 5 or negative square root 5. If you don't believe, we can check both solutions at once. We don't know whether our solutions are true or not, right? So we start in plus minus square root 5 for x. Square and square roots cancel out each other, and we know that both results are 5 because square root of 5 times square root of 5 gives us 5. And negative square root of 5 times negative square root of 5 still gives us 5 because negative times negative gives us positive. 2 times 5 is 10. 10 minus 10 is 0. On left hand side we have 0, on right hand side we have 0. So this is true. Still not convinced? Well, this time we will do it graphically. Graph of fx equals to the standard form of the equation. The zeros of the function are positive square root 5 and negative square root 5. Perfect. However, not every time we can factor or take square root so easily. For example, it's very complicated for us to factor x squared plus 4x minus 3. This is what I went through to get the reverse FOI done. And factor the equation into two perfect squares. I can't remember how many trials and errors I went through. I don't think you prefer to do this every time you want to solve a quadratic equation, right? Of course, we can do it graphically. But not every time we have a graph calculator in hand, right? This is why we need to come up with something else to solve any quadratic equation, maybe a general solution. If failure is the mother of success, if Chica is the mother of Milky-kun, then completing the square is the mother of quadratic formula, which is the general solution that we want. So you can see from earlier, the biggest problem is how to get the perfect square. Perfect squares are perfect because they can be expressed in x plus p squared or x minus q squared. For example, x squared plus 6x plus 9 is a perfect square because it can be factored into bracket x plus 3 squared. When we solve the equation, x plus 3 equals to 0, so x equals to negative 3. By completing the square, our goal is to make any quadratic equation into perfect square so that we can solve them easily. But how can we do that? We'll try on the question from earlier. First we add 3 to both sides so that we have x squared plus 4x equal to 3. Each term in this equation represents the area of a shape. For x squared, it's represented by a blue square with side length of x. The area of square is x times x, which is x squared. The term 4x represents the area of this green rectangle with a height of x and length of 4. The area of this rectangle equals to 4x. On right hand side, we will have an orange square with area of 3. We don't know the exact dimension of the square, so I'm just gonna write area equals to 3. Because the total area of blue square and green rectangle equals to the area of orange square. What we have to do is to combine the two shapes on left hand side into one shape. As you can see, blue square and green rectangle have a common side which is x. The trick here is we will split this green rectangle into half. Each of them have a length of 2. Algebraically, is 4 divided by 2 and x squared plus 2x plus 2x equals to 3. Now we will combine the two shapes on left hand side. Hey wait, there is still a missing corner at top right, which is a small square. We know the dimension is 2 times 2. Whatever we add to left hand side, we must do the same thing to right hand side. Algebraically, we added 4 over 2 square to both sides. Simplify, on right hand side we have a 7. Pause for a while. Let us recall back how to expand a perfect square. For example, bracket a plus b squared. If we take the product of these two brackets, we will end up with 3 terms, a squared plus 2ab plus b squared. In short, it is square of first term plus square of last term plus 2 times of first term times last term. Now we will do the reverse of it on left hand side. At the end, we will have bracket blue plus red square. Finally, we have a perfect square on left hand side. Apply the principle of square roots. X plus 2 equals to plus minus square root 7. Subtract 2 from both sides. And finally, we have the answers. To summarize what we have done, first, isolate the terms with variables on one side of the equation. Remember to divide the whole equation by a coefficient of x squared if it is not 1. Second, complete the square by taking half the coefficient of x and add to both sides of the equation. Step 3, express one side of the equation as perfect square. Step 4, apply principle of square roots and solve for the variable. Because completing the square works for any quadratic equation, including those with 1 root, 2 roots, or no root. Completing the square still can't solve an equation very quickly, so we need to derive a general formula by completing the square. This is a general form of quadratic equation ax squared plus bx plus c equals to 0. Put our checklist on the right, subtract c from both sides, divide the equation by a. Step 1 done. Half of b over a is b over 2a, square it, and add to both sides of the equation. Step 2 done. Now the right hand side looks complicated, right? Simplify it. We will have b squared minus 4ac over 4a squared on right hand side. Get the perfect square. Step 3 done. Apply the principle of square roots. Remember, it can be positive or negative. Since a greater than 0, square root of 4a squared equals to 2a. But I only want x on left hand side, so goodbye my friend. Same denominator, just combine the fraction. And we are done. To use the formula, compare the equation with general form. Substitute a, b, and c into the formula. Press calculator or you do it manually. And this is the correct answer. As for today, we have covered the definition of quadratic equation, relationship between quadratic function and quadratic equation, 2 equation solving principles, and 4 methods to solve quadratic equation. In the next video, we will be talking about the discriminant. If you like this series, see you guys in the next video.